Okay, well, good morning and welcome to this talk about graph definition. Who'd know a standing only presentation about an exotic validation subject, and we have a full room. Not that exotic actually, we want to improve the use and the definition of graph definition. You have to know I'm a trainer by profession, and each and every DevDays I pick a few subjects that I know relatively little about to force myself to learn about the subject and then subsequently inform you about the stuff that I've learned. Interestingly, I was trying to do this for graph definition, and I started asking some difficult questions to Graham and some of the other pundits that I hoped would give me all the answers, and I would just have to summarize it, make beautiful pictures, and show you how this works. And they went like, well, actually, we don't know. You go like, now I'm stuck. I promised to talk about this for 40 minutes, and the gurus don't know. Okay, so, gonna be interesting. But yes, I have a presentation certainly about you on graph definition, how it can be used, how it could be used, and maybe how it should be redefined, as there are some issues with the current definition as it exists in R4. First of all, who of you has a LinkedIn connection to Graham? Raise your hand. That's not a lot, actually, right? Because Graham, at least it's my impression, accepts absolutely each and every request he gets. You can confirm, well, he goes like, maybe. But obviously that's an instance graph. It's a graph of instances. It's persons that have a relationship. And it's not a directed graph, right? It doesn't have a direction. Although you could ask, well, how many of the people in the room would Graham have sent an invitation versus who has sent Graham an invitation? Okay, but that's a different question. But the thing is, graph definition is not an instance graph. That's an instance of resources in our world. It's a type graph. And if you look at a thing like Instagram or Twitter, where I can follow somebody else who doesn't necessarily follow me, that's a directed graph. It's a type graph. So if you look at this type definition, okay, we have a female Swedish environmentalist, okay, who would that be, who may be following a US president, that's a type indication, and we may have a journalist who follows both of those. So immediately when you see this, who comes to mind? You go like, oh yeah, obviously that's Pia Sundergaard and this is President Carter. No, okay, but remember, this is a type graph. Okay, so there are lots of potential matches. I'm sure that in Sweden there are thousands of female environmentalists. Yes, Greta Thunberg obviously comes to mind, and what would then be the president that she follows? Well, it could be President Trump. It's always good to know the position of your opponents, so to speak. Or maybe Obama, if that's somewhat more similar to your own ideas. But it's a type graph, and that's one of the main difficult things to get your head around. Okay, so the agenda is, yes, let's look at what is this graph definition thing. And I'm going to use some examples to illustrate and help your understanding of how to deal with this. Compare it with structure definition. Most of you, if you have done anything with the validation part of the FHIR specification, you will have seen structure definition. So how does it relate? Doesn't structure definition do the exact same thing as a graph definition? Well, no. Graph definition stitches together structure definitions. What are the use cases for graph definition? Well, certainly validation, but also serves as an element of documentation if you want to document how a message or a document should be structured. So you have a nice HTML tree or graph-like structure that shows you how this should be done. In queries, return a graph that looks like this, or dealing with logical modeling. Okay, and we'll see how that works. Some of this is rather speculative, so I'm just trying to push the use of graph definition forwards, because I think it's necessary in the context of FHIR. And then at the end, we're going to look at the actual graph definition resource as it is today, and as I hope it will be at some point in the future. First, a graph. This is an instance graph, which in this presentation we're going to denote by having circles. So these are FHIR resources that have references. directed graph, and if we look at this, it has a root. So this graph has a starting point somewhere, which is the root, and we have patient, Adam, everyman, that has a weight of observation, which references the patient, has an encounter, has an elevated temperature, and the condition ear infection, and all of that is done by practitioner Hippocrates. You know how that works. Just an example graph that we're going to use in this presentation. Because now, what if we want to build a graph definition for our example graph? Well, the simplest way is to go like, okay, well, I have this patient resource, and the patient resource conforms to two different structure definitions in my example here. So I have a patient of the type ALP core patient. It's not US core patient or Dutch core patient, but it's fictitious alpha country. That's what we regularly use in training courses, so we have no debates on actual profiles. So we have profiles for the patient resource. This patient resource has a one-to-one scoping organization, and there is an encounter, which itself conforms to ALP core encounter as a structure definition. Now here, you see that direction of this arrow is going in this direction. Now, if you know anything about FHIR, you actually know that the encounter contains the reference to the patient. But here, our requirement, as seen from the patient, which is the starting point in our graph, is the patient shall have 0 to star or may have 0 to star encounters. So although the reference is in that direction, our requirement is in this direction. Or to better illustrate that, I want to state that the patient shall have exactly one observation, but the reference is the other way around. Okay? So that's why in the type graph we're looking at the direction of the arrow is more related to the requirement, and obviously you see the name here in my link that may sometimes be a reverse reference actually. Okay? But it's still a type graph. For example, this observation and this observation, when we instantiate this, could be one and the same observation resource. Because here it says there shall be a weight observation with a certain line code, whereas here it says 0 to star observations that do not have a profile. So when we instantiate this, this could be the same. And if I don't want them to be the same, I need some specific rule that tells an implementer or a validator, yeah, well, they could potentially be the same, but if you instantiate this, they shall not be the same. It's a type graph. And with type graphs, you have lots of issues in getting your head around. So defining them is actually relatively tricky. So graph definition is a graph of types. You have a series of nodes. And nodes are, well, our equivalent in terms of thinking of a resource, or better yet, a profile, or a series of profiles that apply to a particular type. And we have edges. That's what you have in graphs. You have nodes and edges. And the edges, they define the cardinality rules as well as the direction, because it could be forwards or backwards in terms of a standard FHIR resource reference. Now, they have a fixed starting point, which is just for us human beings to make it a bit easier to understand, because a graph doesn't have to have a starting point. You can, in principle, start anywhere. But as human beings, we go like, well, we have a bundle and we have lots of resources, well, then we have a starting point somewhere. Just makes it a bit easier. Plus, and here we get to the thing again, you need rules about the relationships between the instances of the resources that you're going to implement. When you implement this graph definition, you need rules to state, yeah, I have the relationship between the types, but at the end of the day, this graph shall only contain one patient resource in the instance of this graph. So there are instance-oriented rules. To illustrate, let's say I have this graph definition, which is actually kind of a tree, but there is a recursive relationship. So we have the patient who conforms to two profiles. The patient has a blood type observation. The patient may have other observations. The patient has 1-2 star encounters. encounters may have a one-to-one, so there's exactly one part of relationship to denote that there is an encounter that is part of another encounter, and the encounter is with some organization. So if I instantiate this, then this is actually a valid instance given that graph definition. Because I have a patient, okay, assuming that conforms to that structure definitions, it has an observation for blood type, or she has in this case. I have two encounters, one being part of another encounter, and both are one is with the organizational encounter and the other is a departmental encounter. Hence, this departmental encounter is part of the organizational encounter. And you go, yeah, cool, I can see that. That's a valid instance given this graph definition. But now I use the exact same graph definition, and then I have this. This is also a valid instance of this graph definition. But now I have a patient and a newborn baby, because that's also a circumstance where you say, well, one encounter is part of another encounter, and they're both with the hospital in this case. But now we have the patient which has a particular blood type, and we have another patient, not every woman, but every baby in this case, and every baby has a blood type and, for example, the observation for jaundice. This is particular types of blood poisoning in young babies. You get jaundice because of different blood types. Okay? So if your intent was to create a graph for this, you have to keep in mind that this would also be a valid instance. Right? So again, understanding that we're talking about a graph of types, and that it's actually relatively difficult to define them, is certainly one of the core aspects in here. So how are we going to use all of this? Well, certainly validation. Yeah, so that on a document or on some bundle of FHIR resources that contains some sort of a graph, you can go like, I stick a label on there if I want to. A profile ID could be a reference to a graph definition. Is this valid given this blah graph definition? Which has the advantage that if you have a graph of 100 resources, what you currently have to do with structure definition is to put at least 100 structure definitions in all of those resources. But now I only need to label one and go like, okay, from this root in my graph definition, this shall be valid with this graph definition, and the definition of the graph itself references the various profiles, the structure definitions that are relevant on the nodes. You can also use it as documentation, again, to generate, for example, nice-looking HTML or other tooling. I'm not by chance looking at a certain person in the room. Nice tooling to deal with graphs. Okay, David Hay has created various tools that allows you to work with graphs and display them. You can also use them to define some sort of response structure. For example, give me for a particular medication dispense, yes, I want to get hold of the example medication dispense, but I also want to have all associated and related clinical information as defined in a particular graph. Okay. Or I want you to create a document, $document, which is to turn a composition into a FHIR document, but the content of the document shall be as follows. Some graph. And that will specify the content in terms of resource types, etc., what you want to have in your document body. It shall have these 5 sections, and the section shall have entry, resources, etc. Effectively can be done in one graph. It's not going to be a simple thing, but it's going to work. Now, one of the things is the difference between structure definitions and graph definition is that structure definition is about outbound references only. So yes, in a structure definition, you would define that I have a patient and all sorts of constraints on the data elements of that patient, and that the reference is mandatory, and that the reference shall be to an organization that conforms to that profile. And that's where it ends. So a structure definition is very good at doing that, but it's a very limited scope. And one thing you cannot do is to make requirements according to the inbound references. this patient shall have an observation of type weight. You cannot do that with structure definition. A structure definition on observation would allow you to say, well, if there is an observation, it shall have a patient. But it doesn't state that there has to be an observation. So that's the stuff we need for graph, right? So here we have a profile on condition, for example, but again, that would only give me part of the overall picture. Or this one, which is for encounter. So then that begs the question, well, could I then, by just having, let's say, 1,000 structure definitions that are sort of stitched together like a piece of patchwork, can I do the exact same thing as what I can do with a graph definition? And the answer is still no. Because the inbound references, that's something you cannot tackle using structure definition. Okay? So the summary of that is, I already told you this, that yeah, you will have thousands of structure definitions, but you won't be able to see the forest for the trees, and obviously it's still not going to have the exact same functionality. So if structure definition accomplishes this on my root node, then for a single node, because this is a node also in my graph definition, I can then express the exact in- and outbound relationships with all other nodes that it directly connects to. That's what I want to do effectively in a graph definition. So structure definition, one single resource, outbound references, determines the type of the thing that you are outbound referencing, right? But it's the single resource where the graph definition, well, it's not about the data elements, okay? It's only about the type of the node and the various inbound and outbound references. That's what it's all related to, plus some special statements about instances having to be the same or not, okay? Let's look at validation, which is next to the querying that we saw earlier on, or I want you to create a document with this structure. Validation and documentation, obviously a prime use case. Now you can, in a bundle or in any graph effectively, you can include in your profile metadata tag, I solemnly swear to follow the rules of graph definition, my graph. So that's not limited to structure definition, it could be a graph definition as well. And if you do that, again, you don't have to mention the structure definitions on any of the nodes in the graph instance, the instance of the graph. Okay? Now there are still some ongoing discussions as to when should you actually use the profile meta tag, and those obviously also apply when we talk about graph definition. Queries. I talked about this before, so in a query you may wish to define the exact scope of the thing that you want to have returned. In this case, the example specifies what things should be included in the response bundle. Because I don't just want to have the medication dispensed, but I also want to have the dispenser and the patient and the medication and blah, blah, blah. A whole graph structure. You may use it for documentation. Actually, one of favorites, Graham's examples that he always points at when you talk about graph definition. This is for a what was it, for a structured report? A structured report in FHIR is a grouper of observations that are related, kind of a collection, but it's a bit like a tree structure that may actually reference all sorts of other structure definitions, and obviously this helps a human reader to understand what the structure of the overall report should be. So if you're not using it for validation, it already serves a function and the terms of documentation. Now this is Kevin Mayfield in the UK, and he's already working with the current graph definition and for documents in his case. So he goes like, well, I have a FHIR document, okay, which is a composition resource, so that's the profile on the graph definition is on the composition resource as a root. And then you see here the various slices, okay, that were defined in the structure definition to go like I have various sections. So for each and every section, I then have to define what the associated resources are. But that's documenting, if you want, or specifying how a document structure should be. FHIR Messages, which is also a tree-like structure. Okay, think of HL7 version 2 if you don't know yet about the power of FHIR messaging. Okay, it's always one of my favorite topics. But anyway, capability statement of a server tells you what messages a FHIR supports, and the message definition is done in terms of graph definition, because that's what it is at the end of the day. It's a graph-like structure. Now, I also saw a use case for this for logical models. And with logical models, I mean business requirement models. Archetypes, detailed clinical models, whatever name you want to assign to, let's say, a more business requirement model for what is a blood pressure model. Or in our case, a definition of history of tobacco use, the patient, and advanced directives. You could have business models, which could be modeled as a logical model in FHIR, but that's a bit beside the argument here. And those would be mapped somehow. I'm not interested in here on how we are actually going to do that. The history of tobacco use would probably be a bunch of observations. Okay, patient would be probably patient, and advanced directives would be a collection of FHIR resources as well. Okay. So could I then use, because effectively this corresponds to a graph in FHIR, and this corresponds to a graph in FHIR, right? So can I then use that to basically do things like if I have an instance graph in FHIR, does that conform to my logical model, to my business requirements? So this is about doing a sort of graph comparison, but not at a technical level, but involving the identity of the business requirements model. Or I want you to return for a patient with a certain ID, I want you to return a graph which is identified by the name of the business model in this case. Now, if we start looking at the graph definition resource itself, this is the R4 graph definition, or rather, this is not the definition thereof, but an example that shows you one of the problems that we have with it. Maturity level 1, so yes, this was still initial version of thinking. The problem is a bit that we don't have identity on the nodes in this current definition. And that means that if you have this model and at the end it's a tree-like structure, and at the end it says, well, here we have to reference back to the patient that has these two types. But that's not an identity. Okay, it could be the same as that one, but we actually don't know, because we could be talking about two patients. Okay, so because we have no identity on these nodes, we cannot refer back here to the same node as we had over there. Okay, so that's one of the things we have to change. Now I was looking at this graph stuff, and then you end up by looking at things like GraphML, graph modeling language, I guess what it stands for. That's a well-known standard for exchanging graphs, and it's also used in science and lots of tools, and you can transform this into an SVG vector image. So very nice applications, and you look at it and go like, okay, well, that's a cool, simple format. We have a graph, we have nodes, nodes have an identifier, we have edges, and these edges go from one node to another node. Okay, yeah, I can see that. So could we not apply this effectively to graph definitions in FHIR? So the new structure would be first metadata, but that would be the same as it is today. Who's the author, or why are we creating this? So this hasn't changed as opposed to R4. But then for the meat of the business, we are looking at this sort of definition. Node, and indicate, well, what are the minimum instances and maximum instances of that node? Because if I have a patient node, then I have to identify, well, in the resulting resource graph, how many instances of this patient type are allowed. What are the profiles that we want to apply to that node? Right? In our examples, the node had to comply to 2 different structure definitions. Then for the edges, okay, that express the requirements as to the minimum and maximum cardinality, we have a source node and a target node. We may have the path, and the path is the name of the data element that holds the reference effectively. It could be a reverse path, right? If our requirement is against the direction of the FHIR reference, we could be referencing a slice in the structure definition to identify, well, that's the slice that we're talking about. There could be a min-max on here. There could be a must support flag on here, just like we have in structure definition, but this is just for the reference, must support on the edge. And then there are 2 special data elements here that deal with the fact that some instances have to be the same as other instances. And that's a special problem because it's a type graph, remember, it's not an instance graph. To show you how that works, okay, with about 7 minutes left, I should be able to do that, right? Now we get into the real mathematical stuff, right? An abstract graph. But you can imagine this to be, let's say it's a patient. The patient has multiple encounters. And then associated with these encounters, I have all sorts of clinical information. But now I want to state that it's all fine to have this sort of graph definition, but I may have multiple of these N2 nodes, but I really want this one to be associated with this one, and this one should reference the same encounter as this one. Because if I'm not explicitly stating that it's a type graph, they could actually be pointing at 2 different encounters. Just point to a encounter. No, you got to point to the same encounter instance as this edge. So that's why we now have, but it's work in process, so maybe this will totally change, okay, is to have this equal thing in here, equal edge target and equal edge source, allow me to specify that E4 should have the same target as E3. Okay, and E5 should have the same source as E4. Okay, so that's the way. It's a bit elaborate right now. You need a lot of definition in order to do this, to actually define the constraints on the instances. Okay, there are also use cases where, going back to our mother and child model, where you explicitly want to say, well, they shall not be the same. Okay, not sure how we're going to cover that. That's a bit more of an edge use case, but that's not in the current proposal that we saw a couple of slides ago. There are people that go like, well, yeah, it sounds like a subgraph. We start even more mathematical on you and go like, oh yeah, so we have a graph and then at some point in time we link to a subgraph. Maybe, I don't know. The problem with type graphs is that you may have a graph that starts with, let's say, the patient, and the patient has a graph on this side, and then you have another graph that also starts with patient that's, let's say, defined graphically speaking on the other side. But we're talking about a type graph, which means they're actually overlapping. It's a join, more or less, of 2 type graphs, and the join is the patient. Now, getting your mind around that and sort of merging the requirements, that's going to be a nightmare. So I'm not sure whether subgraph is actually a good idea. So to summarize, graph definition is a graph of types, resource types, okay, and defines a set of potential graphs of resource instances. Okay, got to think about that, because that's really what it does. It's overall is still a type thing. For documentation, for queries, for validation, minimal content to be returned in some operation, give me at least this, but maybe more, I don't know. So structure definition is about one single resource, and it's only about outbound references, And graph definition allows you to do all stuff, including inbound and outbound references. Low maturity level, but given the level of interest here, I'm fairly sure we're going to increase the maturity over time, because you're all volunteering, right, to comment on the next steps of the draft of this work. And I pinched this summary from an overview of graph definition that Graham gave earlier on. It must be probably the only wording that I still have from your old presentation. The rest has been changed overall. Will get more important over time. And that's exactly the reason why I put this on my schedule to talk about. We know that this will get more important over time. It doesn't hit us currently in most of our projects, but it will hit us as long as our implementations of FHIR get more mature. Right, with that, thanks a lot. I think we have about 5 minutes left or something, so any questions or comments right now?
Is this graph feature implemented in servers, as far as you know?
I know, but I can only look at the previous version of graph definition is implemented.
But how good are the queries to retrieve a subgraph?
Oh, that's not supported anywhere as far as I know. So the question was whether we already have graph definitions which can be referenced in as query response structures. You know of any?
On my server, you can do most of the operations on my server, and we've had connectathons to build documents and query using graph, asking the graph to control what comes back.
All right. So on Graham's server, you can already test some of that. It's,
The validator doesn't support graph definition, and that's mainly because it's not the actual logic, but in order to evaluate the logic, it's got to start crawling the references. So what would the user, when you're running it from the command line, what would that look like? Right, so at some stage I've got to sit down and bang out on Julep what it would look like to point the validator at a resource and say how you could go chase off all the references and just keep chasing the references and validating. The logic is the easy part.
well, luckily for me, I'm a trainer by profession, so I don't have to worry about the implementation of all of this. I mean, but this is the conceptual space, and I hope at least that the concepts are now clear and that you can mull over it and indeed on Zulip comment on any other future crazy thing that we come up with. All right, thank you, and enjoy your talk.